Hello and welcome back to the DSA class. Today we are going to be solving a very simple question, which is to swap the even and odd bits in a given number. Now what does this mean? Assume n is 181. N in binary looks like this. And I'm also putting the position of the bits, which is 1, 2, 3, 4, 5, 6, 7, 8, right? Now you can see that bits at the position 2, 4, 6 and 8 are the even bits. Bits at the position 1, 3, 5 and 7 are the odd bits, right? So you have to swap their position. So see, what I will do is I'm just bringing all the odd bits down. Now if you look at it, if the even bits have to be swapped with the odd bits, the position have to be swapped, then what must happen is all these even bits must be shifted one position to the right. So see, I'm shifting it one position to the right. Now they've all occupied odd positions. Now look at the odd bits, right? The odd bits, if in case I left shift it by 1 and place it back inside, don't you think they have now occupied even positions? That's all you have to do, right? It's all you have to do. But unfortunately, there is no operator which can directly, right shift and left shift the bits within a given binary number. That is not possible. So we have to come up with a logic around this. Now, what could be the logic? Let me show you guys. Now what I want you to understand is two numbers becomes very important for you to do this, right? These two numbers becomes very important. The first number is this one, minus 1, 4, 3, 1, 6, 5, 5, 7, 6, okay? The other number is 1, 4, 3, 1, 6, 5, 5, 7, 6, 5, okay? Now, if you look at it, this is the hexadecimal equivalent of that number. So it's easy to remember. It's 0x followed by 8's. This is the hexadecimal equivalent of this number, which is 0x followed by 8, 5. So it becomes easy for you to remember. Now, look at that. That negative number, if in case I represent it in binary, it looks like this, 1, 0, 1, 0, 1, 0, 1, 0. But please understand, that is an integer value. Naturally, there will be 32 such bits, but the same sequence will continue. If you look at it very closely, you would notice that all the even position bits are set as 1 and all the odd position bits are 0. Any confusion till here? Simple, right? Now this number becomes very important. Why? I'll show you. Similarly, this positive number in binary looks like this. So it's 0, 1, 0, 1, 0, 1, 0, 1. What is interesting about it is all the bits in the odd positions are 1, even position 0, reverse of that. Now using these two numbers, we are going to be successfully exchanging or swapping the position of the even and odd bits within our given binary number. Now, how are we going to do this? Simple. Now, watch it guys. What I will do is, this odd number, I will keep it to my left side. This even number, I will keep it to my right side. Okay. Now, you must understand. N is 181. 181 in binary looks like this, right? So, see what I will do. I will do AND operation between N and this 0x followed by 8's. I'm going to do AND operation. The moment I do AND operation, you will see something very, very interesting. What will happen is, all the even bits will be preserved as it is. All the even bits will be preserved as it is. All the odd bits are going to become zeros. Would you agree with me? So, upon doing AND operation, all my odd bits have disappeared. My even bits have been preserved. Now, I want these even bits to occupy odd positions. I want the even bits to occupy odd positions. So what will I do? What I would like to do is, I would like to right shift by one position. If I right shift all the bits by one position, you will notice all the even bits have now taken odd positions. But the most significant bit, I have left it as empty because I want you to think now. Now, I have to do right shift. I have two options with me. I have your traditional right shift, which is your signed right shift, and I have your unsigned right shift or triple shift. Now, which one of these you will use if you ask me? Just look at the most significant bit, guys. Tell me, if I use signed right shift, then the MSB will be carried forward, which means I will get 1. I don't want 1. I don't want 1. I want 0. Irrespective of whether the MSB is 1 or 0, I want 0. So again I repeat, will you use the signed right shift or the unsigned right shift? Definitely the answer is the unsigned right shift or triple shift, and hence triple shift by 1 I will do. Triple shift by 1 I will do. If I do that, then 0 comes there. So this is my final result. And if you look at this, something interesting is that from your original number, all the even bits have occupied odd positions here. All the even bits in your original number has occupied odd positions here. Interesting, right? Simple. Great. Similarly, I will take the same n and I will do AND operation with 0x followed by 8 5s, which is this. If you notice, the moment I do AND operation, all my odd bits will be preserved as it is. All my even bits will become 0. So if you notice one thing, here when I did AND, I removed odd, preserved even. Here when I did AND, I have removed even, preserved odd, right? Now in our final output, all the odd bits should occupy even positions, which means, how will I make these odd bits occupy even positions? Would you agree? If I do left shift by 1, it will work out. So see, if I left shift everything by 1, the last one part will be empty. I will automatically 0 is attached. You know left shift how it works by now. Something interesting, if you notice, in the original number, all the odd bits have now occupied even positions in the final output. I hope you're able to think. So now here in the final output, I have all even numbers occupying odd positions. Here I have all odd position bits occupying even positions. I hope you're able to think. Ultimately, if I can merge both of this, would you agree I would have swapped my even and odd bits from my original number? Really, will that happen? You may ask. Watch it. So this is the one that is after doing the odd operation. This is for even operation. Now if I combine both of them together, I will get 0 followed by 4 ones, 0 1 0, right? That is the final output. Now I am bringing the original number in front of you. If you notice, do you see that ultimately compared to the original, all even bits, I am marking all even bits here, have occupied odd positions there. I am marking odd positions. Now all the odd bits here in the original, I am marking them, are now occupying even positions. So would you agree you have swapped them? It's as simple as that. So what should you do? Take your original number, right? So I'm writing the 3 steps you have to do. Step number 1, perform AND operation. So N AND operation with your 0x followed by 8a's, right? Second is do N and AND operation between 0x followed by 8 5s, right? Third one is combine the above 2 results using OR operation. You would have successfully swapped it. Really, will this happen? Let's write code and explore. Now the code is very simple. I'll just create a static function. Naturally, this has to return an integer value because in decimal only we will return, and we can now basically call it a swap even odd bits, and this will accept my integer variable n, and in one line we can write the solution. So I'll press enter, and here I will tell return. Now see guys, 2 operations. So I'll put parenthesis and then OR, and then one more parenthesis. This is basically for your even bits. This is for your odd bits, right? So for even bits, what did we do? I'll put one more parenthesis. First we did N AND with 0x followed by 8a's, because this is the value which is going to give us, which is going to remove all odd bits and preserve only even bits. Now, after removing odd bits and preserving only even bits, we want even bits to occupy odd positions. So we want it to be right shifted by 1 position. So I'll tell triple right shift because we want unsigned. This is 1. Now, same thing we have to do here. So I'll put parenthesis, and then I will now tell N AND with 0x followed by 5 5s. If I do this, what will this do? This will preserve all odd bits, remove all the even bits. Now we want odd bits to occupy even positions, which means they must be left shifted by 1 position. hope you're able to think. Ultimately, I'll close, put semicolon, yeah. So that's it. Whatever is this value, that is the integer value, that is what will be returned. Any confusion till here? Great. Click somewhere else. Yeah. Now the thing is, we have to just go and call this function. So if in case I call it, then sys out. And now if in case I just execute it, then I will give 181. If I press enter, I'll get 122. This is 181 in binary. I am in the next line, I'm showing the swapped version. If you convert this into decimal, 100% it is 122. So it works perfectly. It works perfectly. So I hope you now understood how to swap even and odd bits, and I don't think it is really that difficult, isn't it? Great, guys. Awesome. So let's solve even more cool programs. However, if you ask me what could be the time complexity here, let me show you. Now when it comes to the time complexity, it's very easy. If you notice it, it doesn't even depend upon the n value, right? It doesn't depend upon the n value. You are just doing a constant operation. There is no looping, there is no exit condition, there is no incrementation, no decrementation, no condition, nothing. Constant operation. Constant means big O of 1. So in big O of 1, you are able to do this operation. Great. Anyways, I will catch you in the next class.